And joining us now is Davide Farnocchia. He is a navigation engineer at NASA's JPL. Thanks so much for joining us. First off, on behalf of, I don't know, all of humanity, thank you so much for looking out for us. Tell us about this one that we just saw.
Well, this was an interesting one. It was discovered last night by University of Arizona's Buck telescope on Kitt Peak. And shortly after it was discovered, by crunching the numbers and processing the data, it became clear this object was in fact on an impact trajectory. So I got text messages and phone calls in the middle of the night to see what was happening. And by looking at the results of our orbit calculations, it became clear this object was going to hit, but at the same time, it was a small one. So it's one of these objects that reach the Earth on a regular basis. They happen a few times a year. This is the fourth one in 2024. But the interesting thing when we get these small ones that are not going to cause any damage, they break up in the atmosphere, is really the possibility to test the system, make sure that we can compute all the numbers, predict the impact location, and confirm those predictions with these pretty spectacular videos that you're showing.
Yeah, confirm location and also be able to collect data right near where something like that is coming down. It's very exciting to see all this coming together. And yet, the way that you described it, the text messages coming at the end of the night, like I always imagine there's a control, like an Earth control center, right? And all of a sudden it's like, sure, we have an asteroid coming. That does not at all sound like what you described. It sounds kind of like a collective of a bunch of scientists all over the place, like texting each other and waking each other up. Is that about accurate?
Well, pretty much. In this case, you have astronomers that are obviously up at night because you can only observe the night sky in the middle of the night. And then there are people doing the orbital calculations. We usually, work during the daytime, but we have colleagues all over the world. And so if it's nighttime here, there's going to be European colleagues that can notify us. But the important thing is that since we cannot really be available 24/7, we have a completely automated process to fetch these data, process them, and issue alerts as needed to make sure we are notified when something of interest happens, like last night.
Yeah, I cannot think of a more important night shift. And I know that the first imminent detector goes back to like 2008. How has the technology changed over the years, and how much more advanced and much more of a warning do you think we're going to see in the next coming years?
So there is, let's say, in terms of being able to recognize them as soon as possible, once they're observed, we're much faster than we used to be. In 2008, it took several hours to recognize that this object was on an impact trajectory. Now we have a system that is fully automated called Scout that actually notifies us very quickly. It takes minutes to process the data and let us know. We've been able to do these kind of calculations when we had only a couple hours, not 10 hours like the one from last night. And also we have telescopes that are getting better and better at detecting objects that are fainter. And so we can expect to see more of these objects. And this is going to be even more true with the NASA Engineer Surveyor mission and the Vera Rubin Observatory that are going to come online in the next few years. So we're bracing and being excited for that.
Very excited. And again, this is only one part of the equation. We've got this early warning detection thing that's getting a lot better. But how are things going with the whole, like, blast them off of a crash course or intercept them in space? That tech, we've seen the DART mission. We're definitely going to need that at some point in our future, right? So what's the tech looking like on that side of things?
Well, so as you said, we want to be able to prevent objects that might be larger than could cause more damage. And so the first step is to discover these objects as early as possible and allow enough time to deflect them off course. And so there's different approaches. One of them, and probably the best tested so far, is that of a kinetic impactor. You essentially send a very fast spacecraft that smashes into the asteroid, changes the velocity by just the right amount to move it off course. And that's what we tested with the DART mission, which was a spectacular success in terms of being able to demonstrate you can actually target and hit something of that size.
Davide, once again, on behalf of all of us here on planet Earth, thank you so much for the work that you're doing.
Thanks for watching. Stay updated about breaking news and top stories on the NBC News app or follow us on social media.